Hello, this is Mr. Craig, and this is the day 13 stoichiometry homework explanations. And if you haven't viewed the first video and you're still a little unsure about how to work out stoichiometry problems, I highly recommend that you go and watch the video right before this one that talked about and discussed stoichiometry, the basics. Let's get right to it. Question number 1, how many moles of oxygen are necessary to react completely with 8 moles of propane to form carbon dioxide and water? Now, what I did not do on this problem, or in the answers here, is, because I wasn't writing out my answers here, I was actually typing these out, it'd be very, very beneficial if you, as you write out the balanced equation, write down information from the question so that you don't have to go back to the question. So the question asks how many moles of oxygen, so question mark moles over the oxygen, are necessary to react completely with 8 moles of propane. So I didn't write the 8 moles that was given there, to form carbon dioxide and water. And I think everything else is pretty much exactly what we want. So other than me not having that information at the top there, having the number of moles and the question, I think this question is pretty good. So step 1, we always want to write a balanced equation. So first and foremost, make sure that if you don't know what propane is, and I gave it to you here, again, by May, make sure that we know what propane is, and it'll help speed things along. Again, as I said in an earlier video, knowing how to do things will greatly cause you to be more efficient in answering these types of questions. Also, make sure that based on this question, you know who the reactants are and who the products are. So anytime that we are forming something, that should be on the product side. Anytime that we are reacting something, that should be on the left side, or the reactant side. Okay, so we have our balanced equation, and then we want to start off with what we know, which in this case is we have our 8 moles of propane. And so step 2 is change what was given into moles. It's already in moles, so we don't have to do anything to that. Step 3 is we want to use the mole ratio, which in this case is we want to get rid of moles of propane, and the question wants to know how many moles of oxygen. So the one thing that's given, the one thing that's being asked for, goes in the mole ratio. The thing that we're looking for will always go on top in the mole ratio, or in the numerator. So the 5 and the 1 came from our balanced equation, which in this case there's no value here for the propane. Actually, there's a 1 there if you use your imagination, but we typically don't write a 1 there. And then, since the question wanted to know how many moles, step 4, our desired unit is already in moles, so we don't have to change anything. All right. Number 2 says calculate the number of grams. So again, probably one of the first things that you want to do, calculate the number of grams of potassium chloride. So grams of potassium chloride that will be formed by the decomposition of 75 grams of potassium chlorate. 75 grams. Now again, I did not give you the chemical formulas for these, so be sure that you know how to write chemical formulas. Yes, know your polyatomics. Yes, know your 52 elements, names, and symbols. Okay? You've got to know these things. Yeah, we'll leave it at that. All right, so we write our, step 1, write our balanced equation. And then again, try to write the information above what you know. Step 2, let's change what was given. So in this case here, we're given 75 grams of potassium chlorate, and we need to change that into moles. So it will be a one-step process here. So change the grams into moles, and I got this mass from the periodic table. And then step 3, which is right here, is we want to change what was given into mole, or I'm sorry, use the mole ratio so we can get rid of the moles of potassium chlorate and go to potassium chloride. So again, the question wants to know how many grams of potassium chloride. And then in this question here, step 4, we do need to use step 4, which is convert it to the desired unit. So now that we've gotten rid of our units, moles of potassium chlorate, we have moles of potassium chloride. Find the molar mass from the periodic table and solve. All right, number 3. Again, question 3 says, how many moles of lead 2 nitrate? How many moles of lead 2 nitrate are needed to react with sodium chromate to produce 33.2 kilograms of 33.2 kilograms of lead 2 chromate, and then it says sodium nitrate is also produced. So again, what we need to do is, first of all, write a balanced equation. It looks like we do have our balanced equation here, and the only coefficient that we needed to add was the 2 in front of the sodium nitrate. This one's a little bit more of a lengthy number 2. In other words, change the kilograms into grams, and then we can change our grams into moles. So that's all step 2. Step 3 looks like our last step here, since the question wants to know how many moles. We have our moles of lead chromate, so it's a 1-to-1 ratio based on our values here, and then we should get 103 moles of lead nitrate. Okay. Number 4, how many grams of hydrogen gas are needed? So how many grams of hydrogen gas are produced when 45 grams of zinc metal completely replaces hydrogen in hydrochloric acid in a single replacement reaction. Zinc chloride is also produced. Okay, so what's happening, what I'm describing here is that zinc is replacing the hydrogen, and it goes out to form the hydrogen gas here. Okay, don't get too upset by how many times I say hydrogen in this problem. Okay, but this is our basic equation, and hopefully you got that. All right, so again, step 1, write a balanced equation, and it appears that we only needed a 2 there for the hydrochloric acid. Step 2, change what was given, 45 grams of zinc, into moles, and then use the mole ratio. Again, 1 mole of hydrogen, and again, it's H2 since it has gen at the end. So hydrogen's all by itself, so we're going to make that diatomic, so you should not have a 2 and then an H all by itself there. And then the last step is, I think that should be 2.016, so I apologize for that, but the answer should be very, very close to 1.39. Okay. Number 5 says calculate the mass in kilograms of solid gold. So mass in kilograms of solid gold produced in a single replacement reaction when gold 3 nitrate reacts with 75 grams of solid copper. Okay. So again, and then it says to form copper 2 nitrate and solid gold. All right. So again, we have what we know written down, or what was given in the problem. Step 1, let's write a balanced equation. It looks like this one's a little more involved than the other ones, so we do have all of our correct coefficients here. Take what's given, our 75 grams, and convert it to moles. So boom, we have our moles of copper. That is step 2. Step 3, use your mole ratio to get rid of moles of copper and convert to moles of gold. And then the last step, this is a pretty involved step 4. So we convert the moles into grams, then the grams into kilograms. We don't have a conversion to go directly from moles to kilograms. So do show those steps. All right, number 6. Calculate the mass in milligrams of decane. Okay, calculate the mass in milligrams. So how many milligrams of decane when it reacts with 45 kilograms of oxygen? 45 kilograms, boy, I'm making this an ugly one, of oxygen in a combustion reaction. Now this is a very involved problem. Okay, first of all, you don't have the easiest question here to balance, so that right there is pretty ugly. So balancing that out correctly, and probably one of the simplest steps is make sure the height or the water is an even value and and save the oxygen for last. Again, that was from an earlier video. Most often, we want to have water with a positive coefficient there. I'm sorry, an even coefficient. And then save the oxygen for last. All right, so again, step one, step one, write the balanced equation. Step two, this is all step two here. Change the kilograms into grams, and then the grams into moles. And again, this number came from the periodic table. Step three, use the mole ratio. We want to get rid of moles of oxygen and convert it to moles of decane. And then step four, convert to the desired unit. And again, be very, very careful on your conversions for grams to kilograms and milligrams to grams. And if you need to write out that thing, I would dare say that for most of you who are going into the medical field, you need to know how many grams are in a kilogram and how many milligrams are in a gram. Those are the two big conversions. Okay, medicine is in milligrams, kilograms, larger bulk type metric units there. All right, that looks like that's the last question. Again, if you need to back the video up to listen to some explanation, and I went through this rather quickly. If you did not watch the video before this, I highly recommend that you do. I'd go a lot slower. I go over much more detail. Don't just look over the homework problems. Actually watch the example videos.